A volume is described as follows. The base is the region bounded by that equation and that equation. In every cross-section parallel to the x-axis is a triangle whose height and base are equal. Complete the integral along the y-axis for the volume of the solid object. Okay, there's the answer, and they get a big hint. We'll get back to that hint. Now, first thing to do is to graph. Step number one, graph. And you can just use Desmos. There's enough to worry about. There's gonna be a link, the Desmos link on the home page. So go to the home page of our Canvas course, click on the Desmos grapher and graph it. When you do, there's what you get. So I graphed that function at y equals 0. So this is the region we're talking about, the region between those two functions, right? This is an upside down parabola, as you know, upside down U shape, and this is the line y equals 0. There's the region between them. Okay, that's the first thing, the region bounded by those two. Got it. Now we're going to take cross sections parallel to the x-axis. That's an important word there. Parallel to the x-axis. Cross sections are parallel to the x-axis. So meaning when we cut this thing, we're going to go up the x-axis. Or we're going to, sorry, parallel to the x-axis, which means up the y-axis. Let me show you. So, here's the x-axis. Here's the y-axis. So if we're going parallel to the x, we're going like this. We're doing cross sections this way, right? We're not going this way. We're going this way. And that makes sense because let me just put one in there. Each of our sections has a dy thickness, doesn't it? And this is indeed a dy integral. All right, so we're gonna do those cross sections. As we do, every cross section parallel to the x-axis going parallel to the x-axis is a triangle. Hey, what? What do you mean it's a triangle? It's just a straight line. No, remember, this is a volume. It's gonna be a three-dimensional, it's gonna be a loaf of bread, a weird shaped loaf of bread. It's gonna be every one of these is gonna be a triangle. It's gonna be a triangle whose height and base are equal. So you might wonder, what? So let me show you what it is we're talking about and what this is going to look like. So we're doing these, and every time we do this, we're going to get a triangle. What do you mean we're going to get a triangle? Like this. Let me show you. Let me pop it up. This will become a triangle. Okay, every one of those slices, whoops, I missed on that last one, is a triangle. We're slicing those up. And the base equals the height. Did you catch that? The base of this triangle slice matches the height. Now, what's that going to look like three-dimensionally? Here we go. Here I went to the Desmos three-dimensional grapher just to show you. Now, you're not going to have access to that, but this is what you need to picture. See how this is a triangle, and then as it gets back further and further, the triangles get smaller and smaller and smaller until it comes down, that loaf of bread, right? Let me help you. So that's what it looks like. Let me just show you it in motion real quick. So there it is. And let me put it in motion. Uh, get rid of that and move that. There's our cross sections. You see that? See how it's going to cut those. Those are the sections. See how the triangles get bigger at the top because the base matches the height. So when the base is bigger, the height is bigger. When the base gets smaller, 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 the height gets smaller, smaller, smaller. So those are our sections. We're slicing the bread like that. And as we do, we end up producing that kind of shape. Okay, so back to it. That's what we're doing. So we're going to do a bunch of those slices. I've got my triangles there. So I got to find, so how are we going to set up this integral? Well, this integral is going to be, we're going to integrate from where to where? Well, remember our integral is a dy. We're going up the y-axis, right? So it's going to go from 0 to 6. See how we're starting at 0 on the y-axis and ending at 6 from our Desmos graph? And each of those, this is a volume, remember. Remember, we're finding the volume, like how much bread is there by slicing. Each slice, the volume of each slice, and then this is an S, right? It's a big S, sum up, add up all the slices to get the whole loaf of bread. So how do you find the volume of a slice? Well, it's a triangle area. It's triangle area times the thickness of the slice. So what's the formula for the area of a triangle? So I hope you know that it's a half times the base times the height. And what is the thickness? The thickness is the dy, right? This right here is the thickness. It's how thick each slice is, dy. And then the area of a triangle formula is a half times the base times the height. Okay, so what's the base and the height? Well, here we have the base. How are we going to figure that out? Well, whenever you're on any graph, like here we got this graph, right? And here's, I'm going to write the equation of this graph right here for us, just so we can be clear. This is y equals 6 minus 2/3 x squared. So anyway, anytime you're at any spot, when you go from the middle to the graph, that's called x, right? From the origin over to the graph, that's x. So like if you start, well, I should start from down here. Um, from the middle over is x and up is y. So this is x. X is the distance from the middle over to a graph, isn't it? And y is the distance from the middle up to a graph, to any point on the graph. So if you're at any point on the graph, if you're as you're doing your slices and you're at a certain point, how far over is x? Now the base, notice, is going to be 2x, isn't it? Let me write it right here. Because the base has to go right and left, doesn't it? You see that? Because remember, x is only from the middle, from the origin over. So the base is 2x. And that's what they said in their hint here. Remember, at the base of each triangle, it will be 2 times x, giving us some help there. This is a hard one. All right, let's bring this thing down. We've almost got it. It's the integral from 0 to 6 of a half. What's the base again? It's going to be 2x. Okay, what's the height? Well, they said the height is the same. Did you notice that? Height and base are equal. And then, of course, we have the dy. So what's that going to be then? That's going to be the integral from 0 to 6. A half cancels 2. So we're left with just these multiplying, which is 2x squared dy. So there we go. Well, not quite so fast. Dy means he's the dictator. Think about D for D. He means this has got to be y. He's saying everything's got to be in y, please. He's the dictator. So you got to change this to y. You got to change this x squared to y. Well, how do we do that? Well, the x is right here on this graph. So I've got to solve for x squared for that equation because the x value is the x value on this upside down parabola, isn't it? From the middle over to that upside down parabola. This is the equation of that parabola. So I got to solve for x squared in that parabola. So I got to take y equals 6 minus 2/3 x squared and solve it. So let's jump the 6 over there. So we'll have y minus 6 is minus 2/3 x squared. Now, how do we get x squared alone? What do we do? Well, we can multiply both sides by minus 3/2, right? Because that'll cancel out the 3's and the 2's, and the 2 negatives will become positive, and that will get x squared totally alone. And so what does x squared equal? Minus 3/2 y minus 6. So anywhere we see x squared, we're free to replace it with minus 3/2 y minus 6. So this becomes the integral from 0 to 6. I'm going to put the 2 in the front of x squared. What is x squared? Well, it is this. Minus 3/2 y minus 6. And then the dy is still at the back. And there we go. We're not going to actually compute that integral. We could easily do that. You've done a million of that, not a million, you've done a few of those. We just wanted to set it up. There is the setup of the integral that will find the total volume of the bread, of this bread, because we're slicing it like that, right? We're doing these slices. And so there's the total volume of it. How we get it? Well, it's each piece of bread is a triangle, and the thickness is dy. And how do you find the area of a triangle? Half base times height. We found out x is half the base. The base is 2x. So the height is also 2x. Got x squared. Then we had to turn that into y. We took the x squared in the equation for the parabola, solved for it, got it, plugged it in. And there we go. They wrote it a little differently, but it's the same thing.